So in our calculation number 7, we use tabular method to find the right-sided Laplace transform of the following. So our first problem is we have f of t is equal to 4 sine of 3t minus pi minus 3 cosine of 2t minus pi over 2. So we have first our sine a minus b is equal to sine a cos b minus cosine a sine b. This is equal to cosine b Laplace of sine a minus sine b Laplace of cosine a. This is equal to cosine b divided by a over s squared plus a squared minus sine b over s squared plus a squared, and this is equal to a cosine b minus sine b over s squared plus a squared. And in our cosine a minus b, this can be equal to cosine a cosine b minus sine a sine b is equal to cosine b Laplace of cosine a minus sine b Laplace of sine a equal to cosine b multiplied by s over s squared plus a squared minus sine b multiplied by a over s squared plus a squared, and this can be equal to s cosine b minus a sine b over s squared plus a squared. So in our problem, we had based on our problem given, this can be equal to 4 a cosine b minus sine b over s squared plus a squared minus 3 s cos b minus a sine b all over s squared plus a squared. This can be equal to 4. We have 4 and 3, because in our given we have 3t 3s over s squared plus pi over 2 minus pi over s squared plus pi squared all over s squared plus a squared minus 3. We have s, the Laplace of cosine B is s over s squared plus pi over 2 squared minus 2 pi over 2 over s squared plus pi over 2 squared all over s squared plus a squared. And our final answer is 4. Have 3 s minus pi over s squared plus pi squared minus 3. We have 2s multiplied by s minus pi over 2 over s squared plus pi squared over 2. This is all over to s squared plus a squared. And this is our final answer. On our letter B, we have f of t is equal to sine squared of 3t cosine squared of 3t. So first, we have cosine squared 3t is equal to Laplace of 1 plus cosine 2 multiplied by 3t over 2 equal to Laplace of 1 plus cosine 6t over 2. This is equal to Laplace of 1/2 plus 1/2 cosine of 60. This is equal to 1/2 s plus 1/2 multiplied by s over s squared plus 36. And our sine squared of 3t is equal to Laplace of 1 minus cosine of 60 over 2 equal to Laplace of 1/2 minus 1/2 Laplace of cosine 60 is equal to 1/2 s minus 1/2 multiplied by s over s squared plus 36. So our f of t equal to sine squared 3t cosine squared 3t is equal to 1 for s minus 1/2 multiplied by s over s squared plus 36 multiplied by 1/2 s plus 1/2 multiplied by s over s squared plus 36. This is our final answer. Our letter C problem, we have f of t is equal to 3 cosine of 40 cosine of 3t. So in our cos x cos y, this can be equal to 1/2 cos x minus y plus cosine of x plus y. This is equal to 1/2 cosine of, based on our given, we have our x is 40 minus 3t plus cosine of 40 plus 3t. This is equal to 1/2 cosine of 12t minus cos of t plus cosine of 12t minus cosine of t. This is equal to 1/2 cosine squared 12t. This is 1/2 1 plus cosine squared of 12t over 2, and this will be cancelled. And since we have a 3 cos 40 cos 3 of t, and this can be equal to 3 cosine x cosine y, and our 1 plus cosine 2 cosine squared 12t. We will multiply this to 3 so that we have 3 cosine squared 36t, and our f of t, that equal to 3 cosine of 40 cosine of 3t, is equal to Laplace of 3 plus cosine squared of 36t, and this can be equal to 3 over s plus s squared all over 2s squared plus 36 squared, and this is our final answer. Problem, which is letter D, we have f of t is equal to 100 e raised to negative 0.5t. So this can be equal to 100 multiplied by e raised to negative 0.5t. Since we have a constant which is 100, we have 100 Laplace of e raised to negative 0.5t, and this can be equal to 100 multiplied by 1 over s plus 0.5, and this is our final answer. Okay, so my learnings about this topic and activity is I know how to solve the Laplace transformation of the function of t using tabular method or transformation pair. And also it helps me to improve my learnings how to manipulate trigonometric identities.